Good morning, everyone. Today we will try to discuss uh, some exercises to prepare for your final examinations. So this exercise is actually consisting of four numbers, okay, four questions, and then we will try to discuss it during this meeting one by one. Okay, so let us try to read questions, okay, from number one. So we'll try to answer it by uh, one by one. Okay, first one. This one is number one. Okay, I will use like one. Yeah. First one is calculate the double integral. uh, Double integral. Okay, of the following. Is double integral, and then respect in the area of r, and then the function itself 2y sinus x and b area dA. Okay, where the r itself is a set of points that consists of with conditions. Y is defined between 0 and 2. Then x itself, sorry, x move it a little bit. Is x is between uh, a 0 and a pi over 2. Okay, this one. So, answer. What do we need to do first time? Uh, the first thing that we have to do is draw the area. In this case, is A. Okay, let's draw it. So this one is actually rather simple. Area, I use blue. Okay, Y, this is a Y, let's say. Y is defined from 0 to 2, say here. And then X is between pi over 2. Pi over 2 is 3.14, and then approximately 1 point something, 1.5. Okay, this is pi over 2. So this one, find it. So this one is actually the area. Call it, this is R. Okay, and then the second one, uh, just calculate directly the integral. Okay, the integral here can be we can define it as 2y sinus x. Okay, and then this is so the first thing exactly the same. What you need to careful is the order of the integrations. Okay, so will integrate first in the y directions, and then later on in the x directions. Okay, and the y directions, it's the area is from 0 to 2, and then the boundary for the x is between 0 to pi over 2. Okay, first of all, we would like to solve this one. Okay. Now we integrate the inner okay, the inner integrations. Look at this one. So we integrate with respect to y, so that the function in x, consider it as a constant. Okay, so 2y we integrate the 2. It's become 2 square over 2, and then this is 2. Then we just delete it, and then this is sinus x. Then the y itself is from 0 to 2. Okay, and then this one is still in the x directions. Okay. First of all, we solve this integral, inner integral. Okay. So this one, y itself, I rewrite again. This is pi over 2, and then y square. I change, and then I put out first sinus x, and then this is that depends on the y, which is y square. Y square is then I change it to, okay, that's not necessary. I mean, I guess uh, y square in square it's this is 4. Okay, and directly see it, and then 0 it becomes 0, and then I will not rewrite it again. Okay, then we have this one. So 4 sinus x, we integrate is cosinus x, and then the constant 4 is just inherit like this. Okay, and x is between x from 0 to pi over 2. Okay, so this is the minus 4, and then cosinus of pi over 2 minus cosinus of 0. Okay, then cosinus of pi over 2, if you remember, this is, I draw it to make to help you. This is x, this is y, and draw the cosinus functions. The cosinus function is from here, and then goes there, then go again. This is the main. This is just the remaining. This is 2 pi, and then this is 0. Okay, this is 1. I mean, sorry. So this is minus 4. Cosinus of pi over 2 is at this one. This is pi over 2. So this is 0. This is 1. So that we have 4. Okay. So this is actually the first, the answer of the number 1. Okay. This is number 1. We go to the second one. This is number 2. Okay, I will rewrite again the questions. Okay, draw the draw and integrate the following integral. The draw in this case is the domain. Okay, the domain of integration. Okay, this is what we would like to integrate. This is fx y dA, and then over r, area r. With r, define as the following. 2a, number 2a. This is, so the area is bounded by the curve, y is x squared, and then axis positive. Okay, and then x is 2. Okay, this is the second. This is the first questions. So we will try to answer this one first. Okay, so we just directly draw. I'm sorry, this is not right. Okay, we just directly draw the area of the computations. Okay, so this is y is x squared. As we know, this is this curve. Okay, y is x squared. Okay, or we can, and then x is 2. X2 is, let's say, somewhere here. Okay, I put a blue. This is blue. Put a blue line here. If this is a 2, then this is, sorry, this is the graph is not scaled nicely. This is 4, okay? Because this is x squared, and then we have this one. So, what do we have? We have, and then let's say the green one. This is the green one, and the green one is x positive. So this area, okay, x positive, and then this one. So where is the area? The area of R is this green one. This is actually the R in the 2A. Okay. Second question, 2B. Okay. This is 2B, and then for this one, the area is bounded by curve. This is the first curve. Y is square root of x, and then and x is 2y. So this one is line, okay? So we will draw it. Okay, this one. This is x, this is y. Okay? So second one, what do we need to know for this? What do we know for this one? The blue one. I call it as a blue one. Let's say this is actually, we can rewrite it, okay? This is actually y squared is x, okay? Or just simply x is y squared. This is actually parabolic, okay? But in the in the different directions, in the x direction now, and then x should be larger than equal to 0. So this one is actually parabola, but it is only the positive part, okay? Where so how do we draw it? It's something like this, okay? So this one is actually parabolic, okay? So this one is actually y is square root of x, okay? Remember, this is only positive part because of this square root. Another one, use a green one. This is x is to y. Okay, x is to y is this is exactly the same. This is just linear, and then multiply by 2. Okay, so it will directly follow here. Okay, I will try my best to draw it. Let's say like this. Okay, so this one is x is to y. Now we look at these intersections. Okay, if this is 2, okay, if this is 2, this one is 2, the y is 2, then the x is should be 4. So what is the answer? Where is the area between those area and those curve? Is between blue and green area. Okay, so this one we call it as R in the 2B. Okay, now we have now third questions. Okay, this is a 2C. Okay, now the third question is actually determine the area, the integration, uh, the integral, the integral of this is double integral with respect to R, and then 2xy dA. A is area with R in 2A, okay, and 2B. We just draw above, okay? This is 2B, and then this is 2A. Okay, now let's start with the first one. In the area R in 2A. Okay, what does it do? How do it looks like? This one. Okay, so I will print that to make us easier. Okay, So we'll put it here. So sorry. So let's roll it in. Okay, no 100%. So I redraw it again. I draw it again here. Okay, so that I do not have to make it again. So this one, look at the figure. Okay, I will zoom it again. Okay, uh, look at this figure. So the first way, okay, I will the first one I will try to integrate in the y direction first. So from to y direction is from where? From way here to this point. Okay, so y is between 0 until something that the function of fx should be fx. Okay, so fx is in this case is x squared. Okay, and then the y and the x itself is from 0 to 2. X is 0 to, let's say this one is way number 1, okay, type 1. Okay, the first one we integrate with the x, y, and then the other one, then with respect to x. So how do we uh, the order of the integrations? Okay, so this one is 2xy dy. I would like to integrate first in the y directions, and then dx. And the y, it should be like this. And the boundary is from 0 to x squared. And then the x itself is from 0 to 2. Okay, so what do we have? We first integrate with respect to y directions. Okay, let's move on. Let's go on. Okay, so this is from 0 to 2, and then 2xy, we integrate with respect to y. Remember, 2x, we consider it as a constant, and then y, we integrate it, which is y squared over 2. Then I delete the 2, and then uh, this one, and the y, it's from 0 to x squared. Okay, then this one is should be the x. Okay, and then I move it here. Okay, what do we have? X. This is 0 to 2, and then we replace y with x squared. Okay, this is x times. Okay, I move put it like this. That's not necessary. Okay, this is x squared. We square it again. Then minus 0. Then this one is dx. Okay, so this is 2 times 2 is 4 plus 1 x to the power of 5, 0 to 2. Integrate from 0 to 2, and then dx. Okay, so just simply integrate it. X to the power of 6 divided by 6. Okay, and then x is from 0 to x 2. Okay, what do we have? We have 2 to the power of 6, 2 to the power of 6 divided by 6. Okay, this one is 64 over 6, or 32 over 3. Okay, this one is the final result. Okay, now I would like to show you again. This one I call it as first type. Okay, we integrate first in the x direction, y directions, and then x direction. Now I will show you how to calculate with another way around. The x directions first, and then y directions. I will zoom it again. Okay, I will use green. So let's say this one is type 2. Okay, type 2. We integrate with respect to x first. Okay, where is the x? x is from here until this one. Okay, what do we have this one? Remember, the x is between something that function. This function should be function of y. Okay, this is not the function of y, so we have to change it. How do we have? How do we do it? This is simply square root of y is x. Okay, or x is actually function of y, or this one is actually fy is square root of y. Okay, so from this fy is actually the same as square root of y. The x is from this point to that point. Okay, until 2, and this is 2. Okay, so now the y itself from where? From 1, from 0 to 4. Okay, this is constant from 0 to 4. 0 to 4. Let's say, so that we have the following order of the integrations. Okay, so how do we write down the integral? Okay, I will write down here. So the integrations is this one, just as in the previous one, 2xy. Now I would like to start in the x, okay, then in y. Look at the x. Where's the x there boundary? From square root of y to 2. Square root of y to 2, okay? And then the y direction, in the y directions, it's from 0 to 4. Now we first consider this part, okay? Just as in the previous one, so we do the integrations. Okay, I will put a whole line here. Okay, 2xy, and then we integrate with respect to x, okay? So what does it mean? Y is constant. Y is constant, and then x we integrate, which is x squared. Okay, this is x squared divided by 2, and this is it vanishes. Okay, then we have the integral is from x is square root of y until 2. This one is still the integration with respect to y, and then I put the bracket here, then this one is y. And then, what is it? And then the x, I replace the x with square root of y. Okay, square root of y square times y. Okay, and then it's minus, and then x I replace with 2. 2 square, this is y. Okay, and then there's still the integration from 0 to 4. This is dy. Okay, square root of y square, and then we squared, and it vanished. So this one is y squared minus 4y. Okay, so this one is 0 to 4 dy. Then this is we integrated y to the power of 3 divided by 3, and then this one is 4y squared divided by 2. Then this one is still 2. And then the boundary is y from 0 to 4. Okay, this is okay. And then I replace it. Okay, 4 to the power of 3 divided by 3, and then this is 2. Okay, this is 2 minus 2 times y squared. Yeah, y squared. That's correct. This is sorry. Yeah, so become 4 to the power of 2. Okay, minus 0. Okay? 4 to the power of 3 is 64 divided by 3 minus, is it correct what I'm doing? Okay, let's hope so, okay? We'll try. And then this one is, did I make any mistakes? Okay, in this, let me check first, okay? I think I did some mistakes, okay? This is x squared to the 4. Yeah, that's correct. This one is 4. Okay, now I make a mistake. Okay, sorry. Apology for that. I will rewrite again. Okay, I think I made mistake, and yes, I did. Okay, this one. Okay, this is a 0 to 4, and then x. I replace everything to x. Just okay. I will do it again. I will do it again. Okay, to y, and then divided, and then minus. Okay, I missed the order. Okay, yeah, this one is now correct. Should be correct. Okay, and then this one is 0 to 4. This is 4y minus y squared dy. Okay, and then now what do we have? Uh, 4y squared divided by 2, and then integration of y squared is y to the power of 3 divided by 3, and then y is from 0 to 4. Okay, so this one is a 4, and first of all I would like to delete this, and then okay, and then let's become 2 times 4 to the power of 2. Is that correct? Yes, I guess. Okay, and then 4, and then 4 to the power of 3 divided by 3. This one, 2 to the times 16 is 32 minus 64 divided by 3, or we have this one, 3 times 62 is 96 minus 64, which is actually 32 divided by 3. Let's look at the answer of the type 2, okay? Do we have the same? Yes, we do. Okay, so this one is 32 divided by 3. This one is also the same. Okay, remember, you need to consistent on in the order of the integrations. The type 1, we integrate first in the y directions, and then second one in x directions. Type 2, we integrate with respect to x, and then later on in the y direction. Remember, okay, if you do it in the x direction, you need to first integrate with respect to the functions of uh, the boundary should be function of y. Okay, that's it. Okay, number 2 is finished. Okay, no, number 2a is finished. Okay, sorry, this is number 2a. Determine integration with respect r into a. Now we will do r into b. Yeah, I will this one to b. Okay, calculate the integral into b. Calculate the integral with r from to b. Okay, this is the figure what they just did. Okay, now we use a green one. So this one is x 2, I guess. Is it? Yeah. Yeah, that's correct. And then 2x1. Okay, now we will try to calculate this one. Okay, we will try to calculate 2xy dA this part. Okay, now what do we want to calculate? This area. Okay, look at the area that is you can use type 1 or type 2, what I just explained above, okay, previously. But now I would like to integrate with respect to x first, and then y. What in the x directions, the area integration is from, yeah, which is that, okay, this part until to this part, okay. So x is actually from, remember, you should have a function in y, okay. This function should be function in y. So what does it, the first point? First point is y is x squared. Should be a function in y. So I rewrite it again. X is actually y squared. Okay? So this one is y squared. X until from from this boundary to that boundary to the other boundary. Boundary will this one. Okay? The other boundary is x is to y. But now we have to calculate it. We have to reformulate it in the y functions as a y function. Okay, this one is actually no. This is already correct. Okay, I'm sorry. Okay, my mistake. Okay, this one is already clear. This is already function in y. Okay, and this one